In this example, we're dealing with two proportions. So we have two samples and we're dealing with qualitative data instead of quantitative data. So we're no longer estimating the difference in population means. We are estimating the difference in population proportions. This problem says 5 years ago, a survey of college students was undertaken to ask if they were first-generation students. In the survey of 5,000 students conducted 5 years ago, 43% indicated they were first-generation students. In a survey conducted this year, a group of 6,000 students were asked if they were first-generation students. Of those students, 21% indicated they were first-generation students. So in part A, we're constructing a 95% confidence interval for the difference in proportions. We want to know what's the overall difference in the proportions from 5 years ago to today in the percent of first-generation students. Okay, and it says round answer to 3 decimal places. So again, we have two samples here. So our first sample is from 5 years ago. So I'm going to write down and then the second sample is from today. Okay, so my first sample, I'm going to write down my sample size. I'm just going to use a subscript of 1. That's 5,000. And the p hat from there is 43% or 0.43. Now, in order to use our calculator, we actually need to know our x value, how many students. So remember, p hat is actually equal to the number of students that fall into that category over the sample size. So to calculate our x value, we multiply both sides by n, right? So x is going to equal our sample size times our p hat. So in this case, we take our 43% times 5,000 because we want to know the number of students that were first-generation students 5 years ago. So I'm just going to take my 5,000. 5,000 times my 43.43. So I get 2,150 students. Okay, and the reason I do that is these two numbers are what I need if I'm going to use my calculator. Okay? Okay, so a lot of problems will just give you these two numbers and say there's 2,150 students out of 5,000 5 years ago. This one actually gave us that point estimate of 43%. All right, so let's look at our second sample here then. Our second sample size was 6,000. So if we want to get our x value, we're going to take, and this was regarded to sample 1, our 21% times our 6,000. So we do our 6, 1, 2, 3 times 0.21, 1,260. Okay. So now when we want to get our confidence interval, okay, just like we did with the difference in population means, we go to stat, over to test, we go all the way down. Remember last time I actually did this test, we want to go all the way down to, instead of 1 proportion now, we're dealing with 2 proportion. Okay, and then we're going to put our numbers. See, it tells us x1, so that's our 2150. Enter. Our N1 is 5,000. Our X2 is 1260. And our N2 is 6,000. And we want a 95% confidence interval. All right, so the calculator will give us the confidence interval of 0.2028 and 0.237, looks like 0.237 because this did tell us 3 decimals, so I want to round this up 0.203. Okay, so for me, when you write this on a quiz or test, I'm going to look for it like this because it's a difference in proportions that I'm estimating. I want to write it in this interval notation. Okay, I'm going to come down here and write my interpretation. We are 95% confident that, now, which one is larger, P1 or P2? So again, we have to come back here and we look at if both of the numbers in our interval are positive, which in this case they are, that means that P1 is larger. Okay, that's because remember what we're estimating here is if we subtract these two, we're estimating that this number falls in this interval. Okay, so they're positive, so that means that P1 is larger. Okay, you're not estimating what P1 is and what P2 is. You're estimating what this difference is. Okay, so we're 95% confident that the proportion of students, so this is our P1 here, right? That the population proportion of students who indicated that they were first-generation students in the survey 5 years ago is larger than the population proportion of students who indicated they were first generation in the more recent survey. Okay. Make sense? All right. And the second part here, we're just actually changing it to 99% confidence interval. So we're going to do this the same way. But when you go in your calculator here and you do stat, test down to 2 prop z interval, we change this to 99. Do you think this is going to get, is the confidence interval going to get closer together or further apart? Yep, further apart. Okay, so it changes to 0.197 and 0.243, rounded to 3 decimal places. And then we would write the interpretation this similar way. Okay, because they're both positive, so actually it would stay the same way because they're both positive still, so P1 remains larger than P2. Okay?